Welcome back, learners. So as you know, in the previous lecture we were discussing about once the analysis is done, so what are the different results that you get. So let us continue with that same thing. So let us just briefly go through what are the various results that we got, and later today we will discuss about how to apply the load combinations. Okay, because as per IS code provision, whenever you are doing an live load and dead load, so there will be usually a combinations of live load and dead load. So as of now, since we are not considering the wind load and earthquake load, so we are not considering the combination with respect to the wind load and earthquake load. If wind load and earthquake load is present, then we have still more number of combinations. So that we will see when we take up another problem with the presence of wind load. But here we have only two loads, that is dead load and live load. So with that only we have one combination. So usually we take it as the 1.5 times the dead load what we have taken plus 1.5 times the live load what we have taken. So let us see that how to apply that combinations of dead load and live load. So before that we were discussing about the previous results in the form of tables, right? So we were discussing about the models. In the models we have seen about the project settings, then we have seen about the structures layout. Okay, so then we have seen about we used to see about the definition properties. Now, so what this definition properties will give you is, it will first show you about the diaphragm that what you have applied. If you want to see anything about the diaphragm information, so it will give you the information about the diaphragms. For example, if you can see here, so this is the diaphragm data. So the name of the diaphragm that what we have given is D1, and it is a rigid type of diaphragm. So like that diaphragm information can be seen here. Then next, if you see, then next you have the material property. So in the material property you can see here, it will give you the information about the materials. Okay, so first is about the material property summary. It means it will give you about all the information. Then if you want only the material properties with respect to steel, you can choose that. If you want to see the material property with respect to concrete, you can choose that. If you want to see material properties about the reinforcement, that you can see here. If you want to see the material properties of tendon, that you can see. Right, I'll click on this, you can get all the information. Okay, you can see here. You can see that this is about the properties of concrete. So this is about the rebar. This is about the steel. Right, this is about the entire summary, everything is there. Okay, so then this is about the tendon. Right, so we have seen here only concrete. You can see this is my M20 grade of concrete that I have chosen, M25 grade. It will give you Young's modulus. Then V, this is mu, Poisson's ratio. Okay, then alpha, that is coefficient of thermal expansion. Then G, modulus of rigidity. Then unit weight, that is density. Okay, then unit mass, then force. Then this is about the different properties of the concrete for M20 and M25. Right, that is about the material properties. Then next you have, after material properties, the next you have frame sections. So if you want to know any informations about the frame, right, so then you will get it in the frame section. Right, let us see what are the informations that you can set. Concrete beam rebar data, you won't get anything because we have not defined anything. Then concrete column rebar data also you won't get. So even though if you are getting, it is not, because these are the values that we have not covered. Okay, so this information will be required when we are going for design. Then if you see frame sections, you can see that these are my frame sections. Okay, beam 1, 2, 3, column 1, 2, 3, corresponding what material I have used also here, what is the shape is there. Okay, so what is the thickness, that is length and breadth. Okay, that is 12 inch, 9 inch, 18 inch, 9 inch, 20 inch, 9 inch, 9 inch, 9 inch, 12 inch, 9 inch, 18 inch, 9 inch, like this. So it will give you all the information about the sections whatever we have defined. Okay, summary is also same. Okay, you can see here, right? When you click on section, it will give you, these are the 4 sections that we are using for this project. This is their corresponding material, this is their corresponding shape, this is my corresponding dimensions. Okay, that is about the frame sections, right? Yes. So after frame sections, you can see about the cell sections, right? If you want any information about the cell sections, you will get in the cell sections, that is slab. Here we have defined only one slab, so not this one. So this is not the deck that we have designed. You can see we have defined about the slab, that is slab number 1, sorry, slab of 6 inches. This is the information. The material is M20, slab is uniform, element is membrane, slab thickness also they have given. And it will even show you whether you have chosen one-way distribution of load or two-way distribution of load. So that is all about the slab, and wall we have not defined, so not required. Then next you have about one more type of section called as tendon sections. So we have not at all defined anything about tendon section. If you have defined tendon section, so in that information you will get it in tendon. Then reinforcement also we have not gone, because once we go for the design we will use that, so that we will get there. Then next you have the link properties. This we have given because when you see at the bottom we have chosen the link as the foundation, as to make it as a fix. Okay, so therefore if you click on link properties and OK, you can see here, right? So this is about the link properties that what we have used. Okay, so not much information is there. Then next, after that link properties, next you have the loads. You can see here what are the loads that we have considered. Okay, yes, so you can see here, so these are the loads, right? So load patterns, if you see, we have only 2 types of loads we have considered, dead and live. Okay, so this is about load patterns. So shell loads, you can see here, this represents the name of the each and every slab what we have taken of that corresponding story, and that is the corresponding name, and on that what is the type of load you have, and what is the direction, and what is the magnitude. For example, in story 2 there is a slab name of 3. On that slab 3 you are applying a load which is a dead load, and what is its direction? Direction is as that of gravity. Then what is the load you have considered on that? It is 30 lb per feet square, like that. Okay, you can see that there is another slab, same slab only it is there 3 here, then another slab here, so that is of next story. Okay, sorry, yes, story 2. Then you have a story 1, so there. Now again story 2, on that same you have a live load also. So like that on every slab you will get the information what are the different loads you have applied, whether you have applied dead or whether you have applied live, and what is its corresponding load value and what is its direction. So all these details you will get in the loads. Okay, yes, that is about the loads, right? Yes, so then after the loads, then next you have the assignments. So assignments, when it comes, it will give you information about joints assignments, frame assignments, and shell assignments. You can see here. Okay, this is all about the joints assignments, whatever you have done, that information. Then next about the structure data, that is material list and mass summary. Okay, so this is about materials. You can choose the information by element or section or story. For example, you can see here. Okay, so by material type, by section, if you want to see, you can see these are the different section. Column, okay, that is total columns of this dimension is 12, length 100 feet, total weight is this much. Then this column of dimension, this 9 inch 1 feet, 15. Okay, total length is this much, this is weight. Then next you have 9 feet 1 feet 6 inch column, so 42, 350, right? So then 62 total length. It is not the total length in the sense of each story, So when you add, okay, when you add the length of each story, sorry, when you add the length of each column, 42 into almost 10, right? So like that. Okay, so the total length by considering all the 42 columns length, this is the one. Then beam, 31 beams, it's their total length when you add everything, right? Weight. So like this will give you information about by section, it will give you information by story. We can see a story 2, column, grade. So this is weight, it's total floor area. Okay, like that. Even you can get it by your story by information, material list by story also, even by element also. Okay, yes. So then next you have is about the mass of the structures also, you can get it. Okay, if you click on the mass, it will give you the information. Okay, so each and every mass it will give you. For example, story 2, label 15, name. So it will give you x, ux, uy, uz. Then you can see that there will be mass also. Okay, so better we will go mass by story, you can see here. Okay, so for the base, this is the mass in x, this is the mass in y. For story 3, this is x, this is y. So for story 1, this is x, this is y. For story 2, this is x, this is y. Like that, you can go by story also, or you can go by group also, or you can go by with respect to diaphragm also. Like this will give you information about the mass. Right? So then once, okay, so this is all about the informations. Whatever you have seen here is about the, it is about the model. Okay, so it will give you the information about the input models whatever we have given. Okay, so this is not actually the results, but you can get it everything in the form of results. These are the inputs that whatever we have given. Now the actual results that what we need here before we go for the design is this analysis. You can see here in this, these are the options that you have. Okay, so this we are not going to see because it is an advanced analysis version. Active, degree of freedom, p delta option, mass source, sapphire option, this we have not used. So as of now it is not required. Then even the response spectrum also we have not going to touch because this is one more type of analysis, what we call it as dynamic analysis. Now whatever the analysis we have done here, we call that analysis as the static analysis. What do you mean by static? Here your load application on the structure will not vary from time to time. It will remain stagnant for a long period. So that kind of force we call it as the static force. And whatever analysis when we do by assuming that the load application on the members is not going to vary from time to time, we are going to do that analysis as the static analysis. So if we are doing the dynamic analysis, then according to that your load application on the member will vary from time to time. Okay, so that is what we call it as dynamic, that is your earthquake analysis. So that we are not going to do. So therefore we are not going to worry about this response spectrum. Even the time history also, it is a dynamic analysis, so it is not required. So you can see about load cases, so that is also we have seen. We have to more concentrate on results, right? So in that results, the first is your displacements, right? So what these displacements will give you? This displacements will give you information about the first in the joint displacement. So you can see that there are so many joints present in the structure. These each and everything is a joint. So when I click on this joint displacement, it will give you by what distance that each and every joint moved. By what distance that each and every joint moved. Okay, for example, if I want to make it clear, I will go to display option. Okay, I'll go to display option. So in that display option, okay, so I will go to view option, right? So I will try to do that. Yeah, Just give me a minute. I just need to show you the details of the joints. Not here. View. Yeah, in the view, can you see here there is an option called as set display option. When I click on that set display option, you can see here that some of the options that can be seen, if you want, you can select here. Some of the options which you don't want to see, you can deselect here. Now I want every joint name, right? So I will go to other assignments. You can see here joint assignments, unique names has been given to it. So just click on that unique names. Okay, just click on that unique names. So give apply to all window and you give apply and OK. You can see that for every joint there is a specific name. You can see this is joint 68. So now it is easy for you to understand. I'll go to display, show tables, right? So this is about mass. Okay. Yeah. So I was discussing about analysis, in the results displacement, joint displacement. I'll give OK. Right. Now can you see here, right? In the story 2, we have selected a unique name. The unique name will give you 2. So for the 2, you have 2 loads. So one is dead load, one is live load, right? So for the dead load, the displacement of that particular joint in the x direction is this much, in the y direction is this much, z direction is this much. Why it is negative means it has moved down, that's why it is negative, or it has moved in the opposite direction, that's why it is negative. Then this is rotation in x, this is rotation in y, this is rotation in z. If you want to see, I will just show you students. So I will go to plan, in that I will go to story 2. Okay, in the story 2, you can see here that in the story 2, this is my unique name 2. Now when I go to display and when I ask you to go for the show tables, okay, you can see here that so this is my story. Now this is my number 2. In the story 2, the unique name is 2. So for the dead, live. Similarly, you can see this is the unique name 6. So for the dead, live. Like that, for every joint in the structure, you will get the information. There will be 250 pages like this. For every joint in each and every structure, it will give you the displacement what you have seen in the x, y, z, as well as rotation in x, y, z. That is about joint displacement. Then after joint displacement, if you see, next information is about joint drift. Okay, so first is joint displacement, next is joint drift. In the same manner, it will give you the drift. Story 2, unique name 2, for dead load, for live load, displacement in x, displacement in y, drift in x, drift in y. Okay, so what is the difference between displacement and drift? The displacement will give you the information with respect to origin. Okay, from the origin, for that particular point, to what distance it has moved. Okay, whereas drift is a relative value. From the first story to the next story, by what distance the joint has moved. It is not with respect to origin. Again, I will explain you. Displacement will give you the moment of a particular joint with respect to origin. When before analysis it was 0, so after analysis from origin to what distance it has moved, that will give you displacement. Whereas drift will give you with respect to the relative points. That is, in the first story also there is a particular point, second story also there is a particular point. So from first story to second story, how much joint has been moved. Okay, so that is what we call it as drift. Okay, so that will give you about this joint drift information. Then next you have diaphragm center of mass displacement. We have applied the diaphragm, so this information will give you by what distance the diaphragm has moved. Okay, what distance displacement the diaphragm has moved. Next is about diaphragm maximum or average drift. Okay, so that is diaphragm displacement and diaphragm drift. That is, this will give you information by whole structure, because you know the diaphragm was applied to the whole structure. Therefore, if I want to know about the whole structure displacement, you have to choose the diaphragm. If you want individual displacement value, you can go for that. If you want the entire structure by what distance it has moved x, by what distance it has moved y, or by what distance it has moved z, then you have to choose diaphragm. You can see the diaphragm for dead load of the story 2 and live load of the story 2. It is the total structure moved in x direction, total structure moved in y direction, and okay, then this is about the rotation in the z direction. Okay, this is again the movement in x, y, z direction in feet. This is in inches, this is in feet. Okay, whereas this is with respect to story 1. Okay, therefore, as I already informed, if you want to have the information with respect to the entire displacement or the drift of the structure, go to the diaphragm. If you want individually joints values, then you go for the joints. Okay, yes. So that is about the information about this one. Then similarly, next you have is the story drift. Then next you have is the story displacement. Okay, that information. Right. Then next is about the reactions, that is support reactions. The support reactions, that will give you information about the base reaction, joint reactions, design reactions. Then next information about model results. In that model results we are not worried, we are not considering. Then next you have the structure results. Okay, then you have the frame results, that is column force, beam force. Then shell results, shell force, shell stresses. Right. So these things I will show you correspondingly along with that when we are going for the designs. Okay, instead of explaining everything one by one, so I will explain you wherever I need the results to my design. So there I will explain you how to get the results. So now let us see how to have the combinations of the load. So then in the next video, let us start with the design of the footings. So in order to do the design of footings, we need the support reactions value. So from the results, I will explain you how to get the support reactions value. So after getting the support reactions value, then what step we are supposed to follow. So that we will see in our next video. Now, as I already told, I wanted to do the combination of the loading, means I have to unlock the model. Now, when you want to give the combinations of loading, then again go to define. In the define, you can see here that here there is an option called load combinations. Right. As I already told, when you have the earthquake and wind, you will be having more number of combinations of the load. But since we are not dealing with earthquake and wind here, so we will be having only the one combination for the dead and live. Usually we take 1.5 times the dead and plus 1.5 times the live. So let us consider that combo itself. So I will go to add new combo. I can give the combo name as same as that of that 1.5 dead load plus 1.5 times live load. This is my load combination. Right. So now this is no need to change, it will be added linearly. Now I want 1.5 times dead, therefore I will have to make scale factor as 1.5, because I told 1.5 dead plus 1.5 live. So therefore 1.5 dead, okay, add, then I have to make live, that is again 1.5, add, okay, this then later you can delete this. So therefore now you got a combination of dead 1.5, live 1.5, give OK. You can see 1.5 dead load plus 1.5 live load. Right, if you want you can see modify or show combo, it is there. Okay, okay. So now again, if you want, you can analyze the structure. Now whatever the results you get, along with the dead and live, you will get one more load, about 1.5 dead load plus 1.5 live load. That is an additional one. Okay, I'll show you now. Yeah, now for example, if you go to display and show tables, okay, so for example, if you want to show with respect to this only, that is joints displacement, okay, you can see here now, initially it was only dead and live, now it is 1.5 dead plus 1.5 live. That is what we call it as load combination. Okay, so in the next video, so let us start learning how to get the support reactions in order to design my footing. Okay, thank you learners.